So for this compound, we're going to start by writing our longest carbon chain while trying to keep our substituents on the lowest number possible. So this would be 1, 2, 3, 4, and carbon number 5. So there's 5 carbons, so we're going to have pentane. They're all single bonds. And now we're going to look at our substituents. We have 2 methyls on the second carbon, so 1, 2. And on the fourth carbon, we have 1 methyl. So we have on carbon 2, 2, 4, we have 3 methyls, so tri for 3, trimethylpentane, and that's all one word. For this compound, we're going to label our carbons again. 1, 2, 3, 4, 5, 6, 7, 8. Again, keeping in mind that we want it to be the longest carbon chain possible and keep our substituents on the smallest numbers possible. So let's look at, since we have an alkene, so a double bond, let's draw an imaginary line down the middle. Let's see which side is heavier, looking at the top and bottom. So this is the top. This is the top for this side, the left side, and this is the bottom. So obviously the bottom side is heavier because we have a bunch of carbons instead of just 1 hydrogen, and obviously the molecular weight is just 1 for hydrogen, approximately. So this would be the heavier side, and then on this side, on the right side, we see this versus just that methyl. So clearly we're going to go with the top on the right side and the bottom on the left side. So that's opposite, so we're going to go with E. So it's going to be the E conformation. And we're going to say 2, 4, because that's where our substituents are. 2, 4, the 2 methyls, dimethyl, there's 2. 2, 4, dimethyl, oct, because there's 8 carbons in total on the longest chain possible. Oct, 4-ene. And why did I put 4? I put 4 because that is where my double bond starts. So some people confuse it, it might say 5. How do I know if it's 4 or 5 to put right there? And we're always going to go, where does the double bond start? On the 4th carbon it starts, and it continues to 5, but it starts at 4. Alright, so for this compound, let's number the carbons. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 carbons. So that's how we know it's going to be oct. But let's look at the double bond again. Let's look at that first. So we see that the heavier side, so we're going to look at the left side only right now. So on the left side, we see these carbons versus just a hydrogen. So clearly this is going to be the heavier side. And again, this is going to be heavier than just 1 methyl. So it's going to be on the top here and on the top here. So that's going to be Z for the same side. So Z. And let's look at our substituents. We see on carbon 2 a methyl and on carbon 4 a methyl. So 2, 4 dimethyl. And 8 carbons in total, so oct. And we have a double bond on the starting at the 4th carbon, so oct 4-ene. And now let's look at this compound. So I'm going to start numbering my carbons at the triple bond because that has the highest priority. So 1, 2, 3, 4 would be my longest carbon chain. And I have 2 methyls on the 3rd carbon. So I'm going to say 3, 3, dimethyl. And where does my alkynes start? It starts on the 1st carbon, so 1 butene. And for this compound, it doesn't really matter where you start numbering it because it's symmetrical. You have chlorines on both sides, so it's going to end up being the same. But let's just say I started here. 1, 2, 3, 4. Taking a look at my substituents, I have a chlorine on the first carbon and a chlorine on the fourth carbon. So I'm going to say 1, 4, dichloro, and I have a alkyne starting on my second carbon. Remember, I want to keep it on this starting with the smallest number. So 2-butyne for that triple bond. Okay, next we have this compound. I want to start numbering it on this side because bromine has the highest priority. So 1, 2, 3, 4 is my longest chain. And I have my substituent bromine on the first carbon. So I'm going to call this compound 1-bromobutane. And for this compound, I only have one carbon here in the middle. So it's going to be methane as the root of the word, the root of the name. Methane. In our substituents, we can see that we have 4 chlorines on this methane, so we're going to call it tetra for 4. Tetrachloromethane, and that's one word. That's all one word. And for this compound, I'm going to start numbering it from here. 1, 2, 3. So taking a look at my substituents, I have on the first carbon a chlorine, on the second carbon another chlorine, so I'm going to call it, and remember we want to keep this in alphabetical order, that's why I'm not writing fluorine first, I'm saying chloro first. So 1, 2, dichloro, because C comes before F, dichloro, and where are my fluorines? I have on my third carbon, I have 1 fluorine and 2 fluorines. So 3,3-difluoro. And where is my alkene? It starts on carbon 1 and it goes to carbon 2. So starting at carbon 1, we have 1 propene. Now let's try some cyclic compounds. So let's say I numbered this 1, 2, 3, 4, 5. Now the numbering's not going to be too big here. The only thing it's going to help us with really is that there are 5 carbons on the longest chain possible. So that's how we know it's pentane. So, and there's a fluorine substituent, so we're going to call it Fluorocyclopentane. And that's it. And we would call this compound chloromethyl, for this methyl right here, chloromethyl cyclopropane. But what if we were just given a name and we had to draw the compound from the name? Notice how it says cis, so we know that it has to be the cis isomer. And we have 2 chlorines, so dichloro on the first and fourth carbon of the longest chain, which in this case would be hexane. It would be the longest chain, specifically cyclohexane. So we know we have to have a cyclic compound with 6 carbons. So let's go ahead and draw that. Cyclohexane looks like this. Right? That's cyclohexane. And we know that there are 2 chlorines on the first and fourth carbon of the longest chain. So let's just number the carbons. 1, 2, 3, 4, 5, 6. See, it doesn't really matter like where I started the 1 on this cyclic compound. Like if I could have easily started the 1 here or the 1 here. It doesn't matter where I started as long as I'm being consistent. So on the first and fourth carbon, there is a chlorine. So there's a chlorine over here on the first and on the fourth. And we have to make sure that they're cis to each other. So That's what this compound would look like. But we could have just as easily drawn it like this. Like this. So the chlorines can either come at us or go away from us. This is how you would draw cis 1,4-dichlorocyclohexane.